Hello and welcome back to the development of the Feersum scheme compiler. So the plan for today's stream is to carry on with and hopefully finish the implementation of macros in the compiler. Now it's been a while since I actually streamed anything or even built this project, so it's probably going to be a large amount of me stumbling around trying to work out what I was doing about a month ago when I last looked at this stuff. Now, normally I would start off with going over what I did last time, but I can't really remember. I think we're at the point where you can have you can't have custom macro definitions, but we do have built-in macro definitions for, at the moment, just the and macro, but it's at the point where defining a macro is just really difficult to do. So in the built-ins, we have an and macro, which has the three transformers for the different cases of an and, which is either an and with nothing, an and with one, or an and with two values, and it's long. I mean, we're getting up to a fair number of characters, 707 on that line. Now, obviously, it looks like you would be able to define more built-in macros like that, but I don't want to have to write them all out by hand. And at the end of the day, the whole point of macros is that users can define them. So in Scheme, I think it's define syntax and syntax case that we need to look at implementing. So what I'm going to have a look at is what our current test for these built-in macros does. So it's just calling the and. So what we want to do is handle the define syntax form and pass the body of that as a macro, store it in our scope, and then go from there, really. Fingers crossed it's going to be a simple one, and then we can complete this branch and get on to doing something a little bit more interesting. So I'm going to get the scheme specification up and we'll have a look at how define syntax works. Probably don't want to have any extra sounds. Syntax, no, is it syntax case? Syntax case, are you just failing to search? Syntax definitions. Define syntax. Let's make this a little bit bigger. Keyword is an identifier. Transformer spec is an instance of syntax rules. I think we can either pass or already the body of syntax rules, or we can pass each element in a syntax rules. So I guess the first place to go is into the binder, because in the binder we have this massive switch. So this is where we handle all of the special forms, so things like set, which we treat as a special form, quote, that kind of thing. And these ones down here, or cond and case, it would be ideal if we could implement these as macros. But the keycaps on my keyboard don't match up. I mean, I think the keyboard's designed for Windows. I'm used to typing on a Mac, and the key bindings are slightly different on Linux, so I'm still not quite used to everything. So we want to say if we see an ident, and the ident's going to be define syntax, then there's a body, and it's like that, because it's got a kind and then a body. And in this case, we need to pass the body as a macro. So let macro equals macro def. We can do macros dot. So we've got pass pattern, pass template. We'll say pass syntax rules, I guess. So I think each syntax rules contains a list of syntax cases. It's not going to be pass syntax rules. Is it? What do we want to do? Do we want to check that it's got an ID and a value like this? I think we might. And then say ill-formed define syntax, just so that we can have our macro pass syntax rules a little bit simpler. So we'll say match body with and we want it to be an array which contains a kind of ID. So that's going to be the name of the macro, what we're going to bind it to, and then syntax rules, and then we will say let macro equals macros dot pass syntax rules ID. Yes, we need to know the ID. Syntax rules. Then we want to store this in the scope. So binder context. Add binding. For ID, and it's going to be symbol. Is it a symbol? I can't remember. Storage ref, isn't it? Macro. So we create our macro, and I think we're going to have to parenthesize that. So we create a macro, store it in, and store it in our environment, and then we return something. So we can do bound expression dot. Do we have one for like not invalid? We've got a sequence point. We've got stores, lambdas. I mean, really, we could do with like an undefined. Or do we just want to have it's not a literal. I don't think you can just apply. I don't think you can just do anything with a macro. So let's just try that out. Create a terminal. Create a new window. And what kind of scheme compiler do I have? Do I have any scheme compiler installed. Doesn't look like I do. This is going to go well. Let's just install the MIT scheme compiler. I would love to imply that transaction. So now we have scheme compiler. Right, so if I do define syntax foo, and then I need to do syntax rules, and then I can say, if you say anything and give it the argument 1 or 12, then we return a quoted ident that says bar. Is that syntactically correct? I think it is. Ill form, special form, syntax rules. No, it was not. What did I do wrong? Let's copy and paste. So, does this just want to be something like this? Syntax rules. Syntax rules needs the list of things to quote first, and then we can say anything with the argument becomes bar. And I think that's the correct number of closings. Right, so this says it's a value foo. So there is something to it. I guess we can have a bound macro expression. Or maybe we just treat it as being a literal identifier or something. Bound expression dot literal bound literal character boolean constant. How far down does this go? Bound. Well, how do we? What happens if we actually just reference an identifier? Bind form if there is an application It wouldn't be in bind form, would it? It would be up here. Binding context. Constant. Okay, so literal. Ident. Yeah, let's just do it as an ident. And ID. And then anything else can just be ill-formed. Define syntax. So what's going wrong here? Well, we don't have a parse syntax rules yet. Add bindings is upset because we don't ignore the result unless I mean, we could treat it as a reference to the location, couldn't we? We could do like bind expression load. But you can't really load from a macro, so that's not gonna, I think that's gonna just be an error. This is not going well. Let's see whether or not the spec has anything to say. Macros expand into definitions in any context. So see if you do, that's let syntax. What about define syntax? It's only showing me those three on that page. It's really just not, it doesn't know about the rest of this stuff. So let's look at the index. I mean, I think in theory that's what indices are for. Define syntax. Syntax definitions, keyword, transformer spec. Talks about being an internal syntax definition if you use it inside a let. I think that's all just going to work because of scopes and stuff. And then I don't think it specifies that there's any particular value, so we can use what we've got going on. Macro. So that's upset. Binder context, yeah, because we don't have context there. And then we've got an ID. So add binding express. So this returns a storage ref. Because I think we need this to be add macro. because this is hard-coded to deal with storage references for arguments. This is for just a local or global binding. So ID macro. And then we can say context.scope scope.insert, just like we do for the macro. And this adds a macro definition to the current scope. And then instead of doing add binding, let's say macros. We do add macro context ID, and then this doesn't need to be a storage ref anymore. That can just be macro. And because it doesn't return anything interesting, we can just stop ignoring it. How's that going to be happier? Bound expression dot we'll make this a quoted, and then no, because we're going to make it an is there a way to get a reference to that ID? F# pattern matching. So we've got when's as identifier. Okay, right. As ID sin. And then we can say quote the ID sin. And then the only thing we need to do is go to macros and do a parse template. We need to do a parse syntax form. Let's public parse syntax. What is it? Parse syntax rules. And it's going to take an ID, and it's going to take a syntax rules sin. And this should pass a syntax rules expression into macro definition. So we're going to use the same parser for the macros for both syntax rules and syntax, and so sorry, define syntax and let syntax, I think. And then we'll handle them as separate special forms in the binder. So that can be to do for the moment. Fail with not implemented. But the binder should at least be happy. That's a macro, that's a macro. Now we know that parse syntax rules returns a macro. So we should be able to run this, and then at least this bit of parsing should be working. So I should be able to say define syntax giving it an ID in a macro. And we should see that failure because it's not implemented. And if I do define syntax like this, it should say ill-formed define syntax. So if I say ID is going to be foo, says that's wrong. And then if I say foo and then anything else, we get the not implemented exception. That's good. And the other thing is we should still get the not implemented. We should get something different if this isn't an ID. So if I put something like a number in there, it says ill-formed. So it's checking that this is an identifier. So there you go, that's our not implemented. So let's go implement it. Well, let's just stage what we've got so far. Macros. What does a syntax rules look like? To the index syntax rules. Syntax definitions. Syntax rules. I mean, I feel like there was more to this. Expressions. It's going to be user defined expressions, macros. This is what I was looking for. Pattern language. It is syntax rules, a list of literals, and a list of syntax rules, or syntax rules, the ellipsis, list of literals, list of syntax rules. So what we can do here is parse what do we want to do? Let's do a match over the syntax rules syntax, and it can be one of two valid cases, or everything else we error out. So I think we want to say error at syntax rules. No, syntax rules. Yeah, that's the one. Dot location. And the error is going to be ill-formed syntax rules special form. Don't actually tell the user what's wrong with it. That's making their job too easy. So the two cases, what are we actually going to get here? I think we've already stripped well, we haven't checked that the body of the syntax rules is syntax. So we need to do kind is kind ident, and then syntax rules. just to make sure it is. And these are all going to be I think yeah, this is going to be a form, hasn't it? So kind would have to be a form. And the form would have to be something that contains an ident syntax rules and a body. And if that is the case, then we can do pass syntax rules body id body, and then if it isn't, I'll say informs syntax rules special form, or should we say expected syntax rules special form. Syntax rules, and what are you upset about that? I mean, that's come out. Yeah, so that should match all of those cases. Unexpected symbol in pattern. Oh, yes, because we're missing that. So we actually, yeah, there you go. Now the pattern matches. So what's this one? AST node kind.form. What's wrong with that? Oh, because it's AST node kind.form. And now we can just do pass syntax rules body. And that's going to be pass. Pass syntax rules body ID syntax, because syntax rules syn was long to type. And then again, we were going to match over syntax, which in this case is going to be a list which already doesn't contain the syntax rules at the beginning. So the two cases, well, the three cases that we need to deal with is going to be, we'll have the error case at the end. So the error case would be just error at, the location is going to be, you have to pass a location in. Gonna have to pass the location in. Unless we have the error type be a string. No, we can keep it like that. Yeah, so we say parse syntax rules body. And it's going to be syntax rules location body. Let's say, what are you happy about? Ah, yes, because and the error is going to be well-formed syntax rules. So the two cases are going to be when it starts with an ellipsis and a form, and then the list of rules. So this is going to be a kind of ident, which is going to be the ellipsis. So it's going to be the identifier to use for ellipses. Then you'd have one where the kind was a form. And that's going to be, we can just call that literals, because they're the literal identifiers. And then the last thing would be an AST kind form again, which is the body. So if we get that, no, that needs to be like this with the kind. Sometimes. There we go. So in this case, we'll say, well, I've already got parse syntax rules body. Should we say parse? We've already got parse syntax rules. Parse syntax cases, and it's going to take ID, ellipsis, literals, and body. And the other one is going to be the same effectively, but without the ellipsis on the front. So if we get that, too many closing square brackets there, then we can do parse syntax case. Parse syntax cases ID, the ellipsis character is going to be the hard-coded one, literals, and body. If I misspelled literals, no, that seems to work. So parse syntax cases. Oh, hi Ruben. What does AST stand for? Abstract syntax tree. So an abstract syntax tree is supposed to be abstract in the fact that it's not directly representing what's been typed in the file. Whereas the concrete syntax tree would include all of the information, including like what we call trivia. So in this F#, the abstract syntax tree might say, oh, like this is a function definition, and like here's its identifier, and here's its like first parameter, second parameter, and that kind of thing. Whereas a concrete one might say, well, like here is a piece of trivia and it's a comment, and then there's a piece of trivia that's a new line, and then there's this and it's an identifier, and then there's this and it's a space, and blah blah blah. Abstract syntax trees are usually what you think about when you're parsing, but having the full syntax tree can be useful. I know that the C# compiler keeps the whole syntax around, and it has like 2 layers of view for your tree. I think it calls them like green nodes and something like that. It's got this like 2-level hierarchy, which is what allows them to do things like when you get a squiggly and you apply a light bulb on it, they can rewrite the syntax tree, and then you just serialize it back out and you end up with the code that you should have. Whereas in some languages, in some compilers, that's more difficult. But yeah, what we're doing here with the AST is we're trying to parse a macro definition. So in our case, our abstract syntax tree is defining like the S expressions that Lisp has. So like there are a Lisp program is made up of, let's go find an example. Yeah, so a Lisp program is made up of a series of what are called S expressions. So like that is an S expression, that's an S expression. I don't know if it's syntactic expression or what, but anyway, it's either a form like this or an identifier. Well, it's either a form or what's called an atom. So then an atom is like an identifier or a literal. But we've made our AST a little bit more detailed than that, which helps in some cases. So like knowing the difference, things like dots, we need to treat dots especially in lots of cases. But down here we're just trying to, effectively we're just matching over all of the, because it's just a big discriminant union, matching over it to try and find all of the, try and turn it from an AST into something that we can use for macros. Expected to have AST node list, but here it has type AST node. Well, I mean, kind should be a list, shouldn't it? And then spliced. Good. Parse syntax cases. That's where I was. I'm just going to take an ID, ellipses, literals, and body. And so what we want to do parse pattern. Literals is going to be a list of strings. So the first thing we want to do is our literals here is going to be a list of AST node. So list let's do list.map which takes the AST node and we go match can I do function like this? Maybe. AST node kind ident ID. So if it is an ID, return the ID. Otherwise, I guess actually we want this to just be result.error And then we can say expected error at end location, and the error is going to be expected identifier macro literals. So this is going to be okay, I guess. And then we'll have, a list of results, and we can do collect to turn that into a single result of a list, and then we can do result dot bind with literals. So we've got our literals, we've got our identifier, we've got a body. I'm going to match body. So what is body? We don't know, it's a list, so we're not going to match it. So this should be parse syntax cases, and then parse syntax case ID ellipsis literals and body is going to do the real parsing. So we would say parse syntax case ID literals just having an even more crafty idea. So if we take that, then all that needs is the literals on the end of it. So if you do result bind with that, and then pipe that to list.map. Oh no. List.map. No. Let's just do this. Let's do this. Parse syntax case. If I say this is okay, what do we end up with? Why are you upset? The type AST node list to result string diagnostic list does not match the type. I don't understand what's gone wrong there. Is that just a weird one-off error? Yeah, I think that should be working. Yeah. Well, I mean, it always should be working. Literals. Then we'll say list.map. Pass. It's going to be a function that takes one of the cases and it calls pass syntax case on it, and it passes in the ID, the ellipsis, literals that have already been mapped, and the case. Now what's going wrong? Oh, I think we need to map that over the body, and then we need to collect it. Come on. Type mismatch. Expecting a function from an AST node list to a diagnostic list to A. So we need to map that over the literals, and then when we collect it, it will be a list of strings, and then when we bind this, okay, now that makes a bit more sense. So we've got the body of a single case. I'm not quite sure what the return type of parse syntax cases is going to be. Hopefully a list of syntax cases. But what is a syntax case? I think it's going to be a pair of a template and a pattern. So we should say parse a case is going to be well, we can make this a function. And the cases are, it is given a form. Two things in it. Pattern and template. or things didn't go well and we return an error. Which case, no, there's definitely something here. So we can do an, it's not a list. We can do error at n.location valid ill. We'll do ill-formed again. Ill-formed syntax case. What does a macro look like? I've forgotten again already. Syntax rules. Syntax rules has parse syntax rules. Yep, I think that matches up enough. So we've got a pattern, we've got a template. So let's pass the pattern. We can do this at least. So let is going to be macro. It's going to be pass. Not pass macro form. Is it? Don't tell me there's already a pass macro form. No. Pass pattern. Pass template. Okay, no, that's just used to work out whether or not you got DOS into it. So we want to do pass pattern on the pattern bit and then pass template on the template bit. Pass pattern, which wants, it wants the ellipsis, it wants the list rules, and it wants the pattern. So it's going to be literals. Literals. The reason why is because I have spelt it wrong up there. No. Oh, I can't do that. Literals. Let's try to do transpose, which is Control T on Mac. But no joy. Literals, and the last thing is pat. Let template is going to be pass template, and the template wants to know the ellipsis and the template. That's kind of looking like everything we need. So then I think we can do okay with what does a macro look like? A macro as a macro transformer list. A macro transformer is a pattern template pair. So I just need to put them together as a tuple and pop the name on right at the top when we've got the list of them. So we say pattern. So where's pat here? It's a result. to do this the hard way. Results.bind pat. So we've got that, and then in here we would do pass template, lit template, again result bind temp. So that's that sorted, and then we would say what does bind want? It wants a result. We just want map template with pat template. If I could spell template correctly. That's error at, not error at. So this is a function of a something to a string list. So that's the ellipses character, the list of literals, the syntax node, and it returns what is effectively a macro transformer. And this is now a list of macro transformers from the parse syntax cases. So this is going to be parse transformer, I guess. Parse transformer, and we can say parse single macro transformer. Node, and then parse a list of syntax trans. Parse transformer. Parse transformers. That type checks all the way up to here. So we say parse transformers. So that is now a result of a list of, but we want it to be macro. So I think we can just do results dot map our transformers become name is ID transformers equals transformers. Now that should be macro. Nice. How about break some of this onto separate lines? That's valid, right? That might even pass a macro. See if it compiles. This seems to indicate the binder is not going to be happy. Add macro, why? Because that is wanting macros, but parse syntax rules is going to return a result. You're just going to have to match it. wish I'd stop doing that. So if it's okay, we will do what we were doing before. And if it's invalid, I'll buffer the error. Error. Then we will context dot oh yeah, diagnostics dot emit e, maybe. Oh yeah, that's results dot error because we accidentally aliased it. This is result emit, so it's expecting emit. What's it? Add? Sure. And then we need to do bound expression dot error. Expected to have, yeah, that's the old one from before. Ruben asks, what does the binder do after parsing? So macros is a bit special, but in the general case, we parse into that abstract syntax tree, and then the binder is what transforms it from the abstract syntax tree into what we call the bound tree. So the difference is that here we've got AST node kind, and these are things that represent the syntax, the program. Whereas bound expression, we lose even more knowledge about the syntax, like they don't have positions in a source or anything. And a bound expression can contain other things like sequence points for debugging, and it represents more like the semantic structure of the program. So the binder's job is basically to walk the tree and check that it's well formed, and it does other things like, instead of having references to identifiers and stuff, we've got references to storage ref because we've resolved all of the identifier references. So if we have a reference, let's go back to artifact. So in this case, when we bind this, we would, for example, turn this from a reference to the identifier fact to a literal reference to the storage where this function lives. And inside here, so like here it would be the global function fact, and inside here it would be the local itifact with accumulator. And if it finds that there's a problem, it turns it into an error expression as well. So we end up with something in the tree, and then we just never actually use the tree at the end because we were always adding these diagnostics, and we check to see if we've got any diagnostics and then just don't actually emit code at the end. So yeah, it's just walking the tree, checking it's well formed, working out what it semantically means. So in this case, for example, it's saying, oh, well, if you said define syntax, then that's because you're trying to define a macro. So it needs to conform to this, and then it checks it recursively all the way down. And if there are any errors, it will return them. If there aren't, it returns, well, in this case, we just fudged it with this quoted ID because the value of a macro doesn't really matter. What really matters is the fact that we added the macro to our context. Right, I'm going to go and I'm just going to optimistically do define syntax. So define syntax. I'm going to call it foo, because why not? It's got no literals. Is this wrong already? Yes, it's wrong. So it wants to then be syntax rules. And then we have the list of things, which in our case is going to be empty. And then we have the list of the actual expansions. And inside there, we're going to say if it's a form that matches something, and then 1, 2, 3, then we're going to transform it into a quoted list containing 1, 2, and 3. Then that's the end of our list of rules. That's the end of our syntax rules. That's the end of our macro. And then if we call foo 1, 2, 3, we should expect a quoted list. Oh dear. Reference to undefined symbol defines syntax. Why? Because I've spelt it badly. SYNTAX. In ill-formed syntax case. Well, that's better. Reference to undefined symbol foo. So that's not defined because the syntax case is invalid. So the syntax rules ill-formed syntax case. Where do we say ill-formed syntax case? Ill-formed syntax case. It's expecting a form. So syntax rules has a syntax rule, and I think it's syntax rule. So I think parse transformers isn't working quite right. So body is a list of syntax nodes. This needs to be, I'm forcing it to be a form here, and I don't think it actually should be according to the spec, because it's like syntax rules that, and then that is one form, that's one form. There's no outer set of ellipses. So this actually wants to be, let's stop debugging because this isn't going to work. This wants to be that, and then that, and then body. And here it wants to be kind is that, and then body. Gotta stop doing that as well. Like that. Let's copy this. No, let's copy the one where it at least worked up to this point. Oh yeah, Control Shift. And let's have another go. It worked. So let's try adding another option. So we can also say, like, if you say foo without anything, if you say foo without anything, then we'll turn it into a string bar. Oh, that's that string then. And then we'll do display. Woo. Display list foo list display. Missing closing. Oh dear. What's it? It's closing there. And there. Ill form define syntax special form. What have I done wrong here? This one wants to have something, so we say bar. So that's the macro foo. And then if we do that again, display list foo 2 3 foo without anything. Good. I think that actually wants to be a new line at the end as well. So I think that's user defined macros. User, yeah. Users can now declare macros using defined syntax. The other one we want to support is let syntax. So the difference between defined syntax and let syntax is let syntax has a body, I think, and then there's let rec syntax. So let syntax bindings has the form a list of keyword transformer spec. And then let rec syntax basically allows mutually recursive macros. I mean, okay, so let rec syntax will allow you to define recursive macros. Not sure that I can bother to do that right now. Custom macros, define syntax for built-in macros. Let's go do that one instead. So I am not the first person to write a Scheme compiler. Scheme is quite an old programming language. I think it's older than I am. The PDF I keep on showing you, this thing here, is the revised, 7 times revised Scheme specification. It's maintained by all of these people. This 7 times revised specification was published in 2013. I have no idea when the original Scheme spec or language implementation happened. I'm just implementing it out of curiosity. When I went to uni, the first programming language we were actually officially taught at university. I mean, it wasn't my first programming language, but what the first one that was taught at the university was Scheme, using a book called Structure and Interpretation of Computer Programming Languages, or which is called SICP or something like that, because it's got a really long and confusing name. The thing that interests me is because I like compilers, and I know that Scheme can technically be compiled because a lot of Lisps, you don't know. Let's go back to an example. I'll go to, maybe lambdas is going to help. No, it's not. So let's go to the iterfact one. In Scheme, you have what's called, is it syntactic environments or something like that? So, but effectively, the key thing is that you can tell by looking at a Scheme program where a given identifier is scoped to. So like when fact is here, the body of fact can reference that fact. And I know that this reference here references that one. But I mean, obviously this may seem perfectly normal from most programming languages, but you could have the case in other schemes where, like, if you had if you turned fact into a lambda and then used it somewhere, and you didn't have, for example, say we didn't have a parameter n, you could have a fact that referenced n, and then as long as there was an n defined somewhere outside, it would just work in the context that you had actually called it. As long as there was an n, it would be good. That kind of style has gone out of fashion, but because Scheme does it this way around, the kind of more common way, you can, at least in theory, write a compiler for it. For a lot of it anyway. Compiling it to .NET is going to be a challenge for some of the corner cases. So Scheme has something called first class continuation. So that means that in theory you can, there's a function called call with continuation that will call you give it a lambda, and it will call the lambda with a function that you can call to return the value. So rather than you just returning out of the lambda, you can also like early exit. The way that works and the way it's modeled does not very cleanly map down onto the .NET runtime stack at the end. So I have a plan for a hack that will probably cover most of the cases. Well, at least some of the cases. Enough for me to be satisfied. I mean, at the end of the day, I don't know whether or not this is ever going to get used outside me just messing around on the internet. So it doesn't need to be completely watertight or completely to spec. So let's just user macros.schema. So user macros. Let's do a define syntax. Let's go and... Have I still got my terminal around? So let's just do this. Because at least I had output and it was reasonably understandable. So define syntax foo was new lines, all the things. If it was 1, 2, 3, we said 1, 2, 3. If it was bar, that was that. And then we did display of list of calling it like that, calling it like that. And then we did a new line. And then let's run the tests. Well, let's just go for update snapshots and we'll see what changes. Now I'll get on to looking at define syntax for built-in macros. So we've got a parser one for user macros, we've got the user macros, and we've got the spec tests. And it says it should be 1, 2, 3 bar, which is what we expect. And nothing else has changed. Add simple user defined or so in binder, is it in binder? Built-ins, built-ins. Let private macro or it's going to be some text, which would then go through macros dot let's see, syntax. Do we have a syntax? Pass stream. So we got pass file, pass stream for feeling. Pass file, read expression, read expression, which I think we want another overload of this. Read a single expression from the named input text. So I'm going to have a read expression which takes a line, or it takes a name, underline, and it returns AST node and diagnostic list. And this is just going to say run parse, run string, piped to unpack. We'll say the name is going to be name. And then read expression can just be a partially applied function of read expression 1 with REPL. Read a single expression from the input text. Then we can do read named expression, and the name is going to be or built-in or. And then this is going to be macros dot parse syntax rules, parse syntax rules, parse, yes, no, yes, parse syntax rules, and we'll say or. And it's going to be unwrap. Read named expression. It's called read expression 1. Type. It does not match the type. Okay, I guess because we need to unwrap earlier. Come on. Yeah, I think we want to unwrap twice. In which case we could do bind here rather than unwrap. And that's going to be results.bind. Ruben is trying to copy each of my commits. You're using my code to learn F#. I mean, that is the challenge. When I started writing this compiler, I had basically never written any F#. And I haven't really read that much F#. So I don't really know if this is good F# or idiomatic or anything like that, but just having fun. A lot of the time, it's kind of trying to think about it. Well, a lot of the time the issues are, oh, I could do this better in Rust, but I'm trying to write a language that targets the .NET runtime. So using a language that targets the .NET runtime helps. The syntax is pretty easy to understand though. So, or macro. What's this one saying? So, maybe that compiles? It doesn't. Expecting. AST node. Diagnostic list. And so we need the node. Then we'll pass the syntax rules and unwrap. And we need to check the errors. If errors does not equal that, then fail with nice error in built-in macro. This is going to be the syntax of the actual macro. If the errors has errors, didn't we say there was an as errors? Is it error? Diagnostics. Has errors. Right, that stands a chance of working. Expected to have the type. What is going wrong? That's what was going wrong. Good. I mean, it's not going to work. So let's add another case to our built-in macros. So somewhere or other, we have the actual OR macro. There's going to be a lot of ORs in here. So index and OR. Or no. Or here we go. I'm gonna guess it's 68. I guessed wrong. 15. Feature requirements. Binding constructs. Maybe I was right. Maybe it is 68. Derived expression types. Or syntax rules. We could just steal this. In fact, we only actually need the syntax rules part of this because the built-ins stuff here only needs that. So let's see if that works. We need the macro OR, and the macro OR we'd have to put that in here as well. Into call macros. In built-in macros, we'd want there to be well, you just want to do the same kind of thing. So OR of nothing, I think, should be false. So let's just see if that actually even works. Or let's just run it in the REPL and see if that works there. Oh, it's not worked. Well, it has gone wrong now. Called unwrap on error. Expected syntax rules special form. Okay, what did we give you? Go to definition. Expected syntax rules special form. Should be ident, syntax rules, and anything as a body. So let's do the same again and see what happens. No. I need to restart it because it's already loaded that because it's a static. So, parse syntax rules. Syntax rules sin. What is it? It's a sequence. What I'm trying to do here is hopefully be able to have this as just like a function that takes the macro body. So let's just do this now. Let's extract. So that's going to be the body rules. So we're going to have like ID and rules. And then here that's going to be ID. The name up here is going to be a printf built-in ID. That just wants to be ID like that. And then this is going to be parse built-in parse macro and parse a built-in macro syntax rules. Macro or is going to be parse built-in macro or like that. So, syntax rules. Or with nothing. Or with an ellipsis. Becomes that. I mean, like, that seems okay. Then now, parse built-in macro. We need to say if match, yeah, let's do match node. So you do a pattern match to work out what kind of node it is. And if it is if it's a sequence with a single thing in it, we will return that one single thing. Otherwise, we will return the whole thing. So then that's a value, and then we can pipe that through past syntax rules. Maybe that'll work. So the idea here is we're using read expression, but read expression is going to return a syntax node, but the syntax node could be a sequence. I mean, the other option is to have the parser have a read single expression, but it's gone wrong now. Or expression not yet implemented. Okay, good. That's a simple thing to change because in the binder we can find or. We can find or. Oh, yeah, we go. Done. So now. That's because we don't get down to bind applications, so we don't try and use it as a macro. False. Or of something that's false. How about false and something that's true? That's the way around it works. Let unbound substitution let. Oh dear, macros don't work. So the problem here is that although the macro from the schema specification for or is correct, the template we pass fine, and then when we try and expand it, we're considering let to be a substitution. We are considering it, and I think I've seen a fix me for this. So let's go see and squint at it and see if it's an easy fix. Here we go. Not all IDs are substs. Need a way to make bound variables available to parse template. Well, I understand the sentence, but do I understand the problem? Well, we need some list of bound variables. So let's say list is going to be ellipsis. Let's just undo ellipsis bound. Recursing's fine, and then we can say if list dot contains ID bound, and this can be if it is bound. if is bound, then okay, macro template dot subst id if it if the identifier isn't bound, we'll treat it as a literal, so we will does it want to be quoted? Macro template. I think it might just want to be quoted. Syntax. I'm just going to do the OK like this. That. Okay. Now, that's wrong here. Now that shifts the problem up to the caller of parse template. Parse transformer is going to call parse template. So we've got the pattern. So we could just find bound from there, couldn't we? And then we'll say let private find bound pattern. It's going to be a function which is going to say if it is a macro pattern dot, what do we got? Constant, don't care, dotted form, do care, form, do care. Literal, don't care, repeat, do care, underscore, don't care. So variable, if it's a variable, then we say v is bound. If it is a macro pattern constant, underscore can match anything, so it's not going to bind anything. Repeat. So what does a repeat do? I think it's just got a pattern inside it. In which case it's just find bound in R. This needs to be recursive. If it is a macro pattern, it's not a literal, we don't care about form. Form body is going to be list dot map find bound. So find bound over the body, and that's going to give us a list. And then we'll turn that from a list of lists into list.concat. So that would be seek.map. Yeah. Pattern. Dotted form. A dotted form has a list and the extra. So that is going to be this. But we need to do list dot, it's not concat, is it append? Yeah, I think it is. List dot append. So you find it in the first and the second, and then paste them together. And everything else can be the empty list. Then this can be bound. And this can be public. Because I feel like we're going to need it in the tests. Yes, we do need it in the tests. Pass template is going to take an ellipsis and a list of bound things. So we've got the bindings. So we need to say that bound equals find bound bindings. And then we do bound. Then transformer. Maybe that works. Expected to have type macro bindings. Macro pattern. Okay, that wasn't quite right then. What about down here? Macro bindings. I mean, I can make that the empty list, but I'm pretty certain it's not going to work. What we're getting passed in here is macro bindings. So maybe I just want to make bound a parameter of that. And then, yeah. Pattern. Like that. Try match is returning bindings. How many times we call try match? Also, maybe these should be uncommented. So that's the pattern and the template, the invocation and the value. Hopefully there are not too many of these references. Try match. So that's literals, pattern, invocation. So it's called in these two places and up here. The thing is that try match is going to define the, it's going to pass the pattern, just read single node. And then gets a pattern. This is kind of all awkward due to the way that these unit tests are working on the lower level API. Find bound is not going to work because this is still a string at this point in time. We need to pass it into a pattern. So try match kind of needs to stay the same. Try expand. How many? Try expand. I think try expand only happens here. So maybe we can deal with this slightly differently. Okay, looks like it's crashed. Code has crashed. That's good. Reopen, please. We could, as soon as try expand's only done there, we could it's passing the transformer. It's passing the pattern. I mean, we can just have a list of bound stuff. That's probably the easiest. Bound IDs. And so we'll have that. It's going to be a pattern. Oh, I forgot how much VS Code hates these attributes. And by VS Code, I mean it's not code, it's the F# plugin. Let's get Emacs. So we need to go to repositories, and it is test, macro tests. And at the bottom, we want to do like that. And that needs to be A. And then in here, I mean, really, we really. We could have let Find bound bindings. Find bound. And it could either be a macro binding. Actually, I have no idea what it could be, but find bound. And oh no, fact bindings. Is gonna be so I think this has got a list, the macro bindings thing. Let's discard that. And then go back again, macro tests. Try expand. It is bindings is a macro bindings. Macro bindings is it's got bindings and repeated. So you'd have to do a recursive function there. Basically, the idea here is rather than trying to work out based on the pattern what should be bound, we could just inspect the bindings that are being passed into try expand. This is only a unit test, so it being a bit hacky like that should be fine. So yeah. It's going to be list.map, and it's going to be a function that takes ID val and returns the ID. And if we map that over bindings dot I've forgotten already. Bindings dot bindings and then bindings dot repeated is going to be nested this dot map try. It's going to be find bound bindings dot repeated, and then in this case immediate is going to be great. Immediate is going to be a list No. ID should be a macro binding. Why have we? What do we need to do here? B dot. Counting that. Like that. Oh, does it need to be? Does it need to be a tupled argument list like that? Now is it happy? Yes. So now that's a list of string. Nested is a list of whatever. So let's say we return immediate here. Now what is nested? It's a list of string. So we need to do that. But if we do seek dot map and then list dot append, yeah, is it, or concat, and then we can do list dot append immediate and nested. That's awkward, but it might work. So let's run the test task. I wonder if the two failures are the two that we just uncommented. That's because we've changed that. That's actually okay. So the reason those two tests have failed is because way back ages ago I actually wrote this OR bit down here. So OR of true and true should be true. OR of false, 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 true, false, false should be true. And how about OR of false 100 false and one. So this should be 100 because that's the first truthy thing in it, I think. So let's run that test. Well, actually update the snapshots. Then we can see what the snapshots have changed to. Some macros, yeah, we'll go for that. Binder, yep. Built-ins, utils, macro OR. Find bound, so we now deal with let expressions. Syntax. Yeah, we can now read with a name. Find bound. That is the macro test stuff. That kind of works. Get rid of that. Extra white space change. We've got the extra forms at the end. Which is good. And then true, 100, and false, which is what we want, I think. If I can actually get back to the actual built-in macros. Yeah, true, 100, and false. And built-in OR. So I think the one thing that's now not really done in this macros, and it's out of scope given given the current amount of time I've spent on this today, is to properly handle hygiene. So I can write a macro that would be technically wrong at the moment because macro identifiers are in the same scope as the outside identifiers. So if you accidentally alias something or redefine something that a macro depends on, it's just going to end up broken. Whereas ideally in a syntax rules macro, let's go find an example. Built-ins, no. This is not Emacs. In built-ins, for example here, this pattern defines a variable called or and a variable called test. And then it expands it to test. So whatever you passed in will be what is passed out, which is fine. So these transformers that are only using, basically only rewriting your syntax, will work the way that they're supposed to. But this case here, this macro defines x, and then it says if x, x. Now this means that I could, if for example test2 referenced a variable called x, it wouldn't see the one that it thought was in scope. It would see this one here because of the way that we've rewritten it. Let's go try and prove that happening. So if I do define x false, and then I do or of x, it's just going to transform it straight and it's going to be false. If I do define x and then I do something else beforehand, so we go into the recursive case. So let's say I do doesn't matter in this case. If I do yeah, the only thing that would make it, if I do that, I'll get 123. So if it's anything truthy, and then the only thing that's falsy is false. So if I do that, technically, false I get back there. is not Rx. So if I did 1, 2, 3, you'd expect this to be 1, 2, 3, but we're getting false because this reference to X here is non-hygienic in the macro expansion, which is unfortunate. But I think that's where we're going to leave it today. Just going to have a look over and see what the docs, what did I write down about the special forms. Macros. If there's a conditional, I don't say anything about macros other than that. Okay. What did you say about macros? The remaining forms could be implemented directly or wait for macros. So if is implemented, that and or forms are implemented macros, built-in macros. And then this needs to be wrapped. How does one do that? Like that? Wrap. Individual lines. Join lines, sort lines. Wrap with abbreviation. What does it even mean, wrap with abbreviation? Let's just do it manually. I know what I'm doing. There we go. So the last one really is the cond and case expression. I mean, cond has a list of clauses, and a clause is either. So we need to do like some kind of nested macro things because we'd want to match a list of clauses. Because you can have, how would you even implement that? I think by being good at scheme is probably the answer. So you have a clause which is either a predicate and expression, and it evaluates the first one that's true. The final predicate may be else, which is always considered truthy. So else would have to be a literal. That's a good one. Let's test that literal stuff's working. Let's run it. So how do we do this? So we do define syntax foo. So foo takes, it's a syntax rules. The literals are bar, baz, and then the syntax cases are if you say foo. If you say foo and then bar, this needs to be like this. If you say foo and then bar, we'll expand it to foo bar. And if you say foo and baz, we'll say biz baz. So if you do that, and then we say display list foo bar foo bars new line foo bar biz bars. And then if I try and change this to something that isn't that ID, no pattern match the syntax. Good. So literals, you actually have to specify the literal ID, but I could change this so I could make bars not a literal, and then this would match again, and it just anything that isn't foo bar is biz baz. In fact, let's make that a user macros test as well. User macros, which means putting a lot of new lines into it. Define syntax. Let. Let's put it in a nested scope. Because we haven't done that bit yet. Display list foo blah blah new line, and we will update the snapshots and see what's changed. Docs, macros, more stuff in the pass, and this says foo bar biz baz, which is what we were expecting. What we should do is check that it works with scoping. So in user macros, we can go back Using macros, we can go back out into the outer scope and then do foo again. And foo should be, if we call foo, that should be the 1, 2, 3 list again. Update the snapshots. More parser stuff. And 1, 2, 3 again. Good. So that means that at least macros are working correctly with scopes. So it is just the hygiene stuff that we need. Check that macros work with scopes. So I think the to do on macros is the let syntax, let rec syntax, to introduce a scope as well. What add-on am I using for syntax highlighting for scheme files? I mean, it's a good call. This VS Code scheme. Yeah. I don't know if it's the best. It just was popular enough and it worked when I installed it. I think it supports loads of fancy stuff, so you can actually develop real scheme programs in VS Code, but I mean, my compiler is not good enough, I don't think, at the moment for a lot of the more advanced features to actually even work. But syntax highlighting is nice. There was something that was to do with comments, I think, that don't quite work. So maybe in comments extended. No, comments. Yes. So that comment comments out, this style of comment here comments out just the form after it. So if I put something like that, if I went, that should comment out the whole if, but that's not working in the syntax highlighting, but it does work in the compiler. So it's not my syntax highlighting. It's not very commonly used comment style, so I'm not fussed. Right, I think this has the build passed. It'd be really nice if it had. The still to do things would be, yeah, build succeeded. Still to do is the, let's go have a look at let syntax. Do I have the spec up? I don't have the spec up. So R7. Let's do let syntax. Somewhere in here. Make it bigger. Let syntax, well, I mean, let's go let. Yeah, we've got let syntax and let rec syntax. Let syntax, given that syntax rules. So what would you need? Let syntax takes bindings and a body. I mean, this should be fairly simple. In the bind, what do we do? At the moment. For a let, we do bind let. Well, this looks more complex than I remember. Maybe bind let itself is fairly simple. So it is either bindings, expression, and a body, or an error, which makes sense, yeah. And then it passes the binding specs. What does that mean? Okay, so it returns the list of IDs to syntax nodes. And I think we would have the same thing. We want to do pass binding specs. And then we'd want to do, for each one in the binding specs, pass that as bound body decal binder, which has a list of bound expressions. Could that be an empty list? Because really we'd want the decal binder. There's not. It's not really a great way for us to report an error there. I'm going to do binding context, but I think we might be able to do that. So I think a let syntax could be based on a let syntax could be based on that let. So let's try it. Kind AST node kind ident let syntax, and a body, and then we do bind let context let syntax body node.location function binding. So the idea of this is supposed to be this function binding specs thing Is it supposed to add bindings, whatever? But in our case, and then bind the bodies. That's in case you've got anything that you need to do to initialize things. But in our case, we don't have anything that we need to do to initialize anything. So we can always return an empty list. And what we can do is seek.iter binder context. Well, what did we do earlier with the macro? Pass syntax rules. Are we actually expecting a syntax rules? Yes, we are. So we're expecting the body to be a syntax rules, so we can just do that. Which probably should be deduped at some point, somehow or other. Seek.iter func syntax rules. That over the binding so this wants to be ID syntax rules. That I think is done. Other than the fact that that's not happy. What is this complaining about? Ignore. Binding specs. I'm confused as to exactly what's wrong there. Too much nesting, I think. Unexpected symbol. Why is that unexpected? Fun. Right, now. Still saying unexpected symbol. Same type as the first branch, which here is unit. Do we just need to ignore? Oh, no, wait a second. We don't actually need to produce a bound expression at all in these cases. So I can actually just do this and then do that, and then it should be happy. Well. Okay, now let's see whether or not let syntax actually works. If it does, this is a triumph. So let syntax, and then we give it a list of bindings, and we say that foo is going to be syntax rules nothing, and then a pattern that just says if you say foo 1 2 3, we will say 1 2 3. Then the body is just going to be equal to foo 1 2 3. Invalid binding form. (114) expected a binding form. 118 invalid binding form. So it's saying there that it's expecting a binding form. Because that needs to have another level of quoting around it. There we go. So let syntax works, which is nice. That was a surprisingly simple implementation. Implement let syntax. Let scopes syntax to a given block. And I suppose we should add a test for that as well, which can be here. We'll do user macros, and then we'll say let syntax foo syntax rules that, and then that, and then we'll display the whole thing. And then new line, and then everything will be good. This needs to be something special, doesn't it? Because that's actually the same. So we'll say syntax rules. So we'll say foo with anything becomes one, two, three, or inner foo. Good. Update the snapshots. Find out what's changed. Frantically refresh. Got some more stuff in the parser. Select syntax. I mean, it's not really the most ergonomic way of viewing this syntax, but it does help us know when things have changed, which usually means things are broken, but not always. Inner foo. Right, that's what we wanted. Add test for. Actually, let's just amend the commit because I've not pushed it yet. Do I want to do let star syntax? I mean, like, let rec syntax. Each binding of a keyword has the transformer specs as well as the body within its region. Transformers can transcribe expression that into uses of the macros introduced by the let rec syntax expression. So macros aren't recursive by default. We're not really behaving when it comes to scopes and stuff anyway. So I think that's actually implementing let rec syntax until we actually support hygiene and stuff. It kind of doesn't make any difference. I think that's it though. I think I'm gonna call it a day, and what we have managed to do is user defined macros. So all the macro stuff that we previously supported, we can now do with this user macros. So we can define syntax, inside some other block, and it's only scoped to that syntax. We've got let syntax support so that we can introduce a block at the same time. So this is just a better way of doing this. And we have defined the or macro so that we can now actually do ands and ors. We could rewrite the and macro. Maybe let's do that. So one last thing. In built-ins and macro and, yeah, if it's an underscore and an A, I mean, or we can just leave it. It works. Although not exceptionally. So let's move macro and to the end. Built-in or macro. So macro and should be something like a piece of syntax, and then we pipe it to parse built-in macro, and then let's go move these forms one by one. So the first one, if it's an underscore and a, then we return a. Syntax rules. If it is an a, we return a. If it is just an underscore, we return false, I think. Was it true? So this is the thing, it's such a complex, yeah. We return true. And the one in the middle is if it's a, if it's an underscore and an a and a b, and if it's an underscore and a repeated b, then if a, then return and if the b, otherwise return the false. Firefox not being the most useful here. So a and repeated b becomes, why don't we use a custom ellipsis just for the sake of it? A and repeated b gets turned into if a and b so that's the recursive case. Otherwise, if a was false, then we return false. And then get rid of that. Let's run the tests. If I did that right, everything should be still the same. Well, should be the same. Reference to undefined symbol true. Well, yeah, that makes sense. Still not there. No pattern match the syntax. Because I've done that again. So the problem is that because the ellipsis whatever it is has to be an identifier. If you don't put a space between the ellipsis and the identifier that you're repeating or trying to capture as a repeat in a pattern, it'll just form one longer identifier. That's not really a problem with the way I've implemented it. That's just a problem with the way the whole thing works. Good. That works. Convert and to a built-in macro. I'll convert and to syntax built-in syntax rules. This is a little easier to read. Obviously, the downside of this is that every single time the compiler starts, it has to go through and parse each one of these macros from scratch again. Anyway, I think that's it. So thanks for watching, and I'll see you next time.